Today's video is 2-7 multiplication and 2-8 division equations. Okay, just as the other day, I'm aware that a lot of these questions can be done mentally. However, we're not going to go for mental math here. We're going to go for our beginning steps of learning how to solve equations and how to show that so that we can solve more difficult and multi-step equations when we get to them. Okay, so inverse operations again. The inverse of multiplication was division, and the inverse of division was multiplication. So an example question might look something like this: 6x equals 18. So the operation that is happening here is 6 times x is equal to 18. And yep, we know the answer is 3, but how can we show it to solve it? Well, if this is multiplication, the opposite operation is division. And you're going to show your division with the fraction bar. Remember how we had discussed previous sections that this is one way to show division. Now, why is this a good way to show it in this case? It's a good way to show it in this case because we already know that 6 over 6 equals 1. And anytime I have a 1 in front of a variable, that's the same thing as just saying the variable. I have 1x, I have x. So in this case, I now have x, and 18 over 6 is 3. Okay, now this is not that this is 61. This is after I've simplified it. There's 1x. Okay, so check it. 6x equals 18. If x is 3, 6 times 3 equals 18. It checks. Okay, another example. Let's say 17x equaled 51. Okay, not as easy to do mentally, but I'm still going to show that I'm going to divide both sides of the equation by 17. Why divide? Because it's the inverse operation of multiplication, and this shows 17 times x. 17 over 17 is 1, so I now have 1x, that was my goal, and 51 divided by 3 is 3. Okay? They won't all have the answer 3. These are just two examples of how to show the multiplication. And that's the entirety of this step for a 6th grade student until we add fractions and decimals and more difficult things. In 2-8, we have a division example, and the inverse operation of division would be multiplication. So I have y over 5 equals 10. Okay? Sometimes we have a little less success completing these mentally, but here's how I want you to show your work. This is y divided by 5. I'm going to show times 5. I'm going to use the dot for multiplication. Okay, inverse operation is multiplication. I'm going to show it with that, and I'm going to write a 5. Now, why did I write it that way? I wrote it that way because, again, this shows that this becomes 1. If I multiply this side of the equation by 5, I have to multiply that side of the equation by 5, and I'll end up with y is equal to 50. Now to check it, I put my answer back into the question. So this is 50 over 5 equals 10. Does 50 over 5 equal 10? It checks. I forgot to check this one. 17 times 3 equals 51. It checks. Another division. Let's say I have m over 2 equals 16. Okay. This is divided by 2. The inverse operation would be multiplication. So I'm going to multiply each side by 2. Have to change both sides of the equation in the same manner so that it remains equivalent, so that it's equal. This equals 1. That's gone. M is equal to 32. Check it. 32 over 2 equals 16. Yep, it checks. Okay. If the things are written in the opposite direction, it still works the same way. So let's say I have 5 equals x over 3. I'm still trying to isolate my variable. So this is still division. I'm going to multiply by the denominator. This becomes 1, and x is equal to 15. I can check it. Is 15 over 3 equal to 5? It is. It checks. And that is the content that's within 2-7 and 2-8.